Okay, dear student, we are studying about chapter number 12, wave and sound. Now our topic is oscillatory or vibratory motion. As you know, to and fro are back and forth. Motion of the body to the fixed point is called oscillatory or vibratory motion. Means when this body is attached with the spring and placed horizontally, when you will apply the force on the body, it will move from its mean position or equilibrium position. This one is equilibrium position to the left, and when you will release the force, the body will move back towards the mean position and acquire the new position. Why the body comes back? It comes back due to the restoring force. The restoring force which is existed in the spring when you pull it. So the body will move around its to the back and forth to its mean position. Likewise, this body is called pendulum. When you will apply the force on the pendulum, it will move back and forth or to and fro. This type of motion is called vibratory or oscillatory motion. Now, what is periodic motion or harmonic motion? Periodic motion or harmonic motion is the same thing. Now, how will you define it? The motion which repeats itself in equal intervals of time is called periodic motion or harmonic motion. Such as, for an example, motion of simple pendulum, motion of second wheel of watch, motion of body attached with spring placed horizontally, motion of swing. All these motions are harmonic motion or periodic motion. Now, what is simple harmonic motion? Simple harmonic motion is a periodic motion. These motions are periodic motion, this spring as well as this pendulum. But what is simple harmonic motion? A periodic motion in which acceleration is directly proportional to the displacement, and its direction is towards the mean position. The periodic motion, in which there are two conditions. The acceleration is directly proportional to the displacement. What is displacement? The distance from the mean position of the vibrating body is called displacement. Now it is mean position. When it will come here, it is its displacement x naught. When this body comes to the right, it is also displacement. The distance between the mean position and displacement and the point where the extreme position is called displacement. Now the first condition was acceleration is directly proportional to the displacement. If you will increase the displacement, acceleration will be increased. If you will decrease the displacement, acceleration will be decreased. This is the first condition. And the second condition is the direction. Its direction means the direction of acceleration is towards the mean position. It is known as simple harmonic motion. If the periodic motion fulfills these two requirements or two conditions, then the periodic motion is called simple harmonic motion. Simple harmonic motion can be expressed as A is directly proportional to minus x, where A is acceleration and x is displacement. Acceleration is directly proportional to the displacement. Greater is the displacement, greater is the acceleration, and the direction of acceleration is towards the mean position. this negative sign shows the direction of acceleration towards the mean position. So the spring attached with the body placed horizontally is a simple harmonic motion. We can prove it. Proof: A is directly proportional to minus x. A is acceleration, x is displacement, and the negative sign shows the direction of the acceleration towards the mean position. This one is mean position. Now you will apply the force on the body. It will cover the displacement of x. Now there is a restoring force in the spring because you have applied the force on the body which extended the spring. So the extension in the spring is the restoring force. Now this restoring force brings back the body towards the mean position. Now you can write its consideration. Consider a body A having mass m joined with the spring placed horizontally. Force F is applied and displacement x is covered. Then it comes back by restoring force minus F. Why is it minus F? Because its direction is opposite to the applied force towards the mean position. As per Hooke's law, stress is directly proportional to strain. F, you can consider that F is stress and x is extension in the spring. So the length of the spring in the original position was this, and now its length is increased, mean its length is extended, which is x, and x is also displacement. Minus F is directly proportional to x because this force brings back the body back towards the mean position, therefore its sign is negative. So by removing the proportional sign, we will place constant, which is x. It is also known as Hooke's constant or spring constant, and also known as proportionality constant. So F is equal to minus kx. Now according to the Newton's second law of motion, F is equal to ma. Therefore, instead of F, you will write ma. So the equation will become ma is equal to minus kx, or by evaluating the acceleration. So m is multiplying over here. Here m will be divided. A is equal to minus kx upon m. But k and m are constant because mass of the body is constant and k is spring constant. By removing these two constants, we get a is proportional to minus x. We have to prove this thing. It is proved that acceleration is directly proportional to the displacement x, and its direction is towards the mean position shown by negative sign. Therefore, the body attached with the spring placed horizontally has simple harmonic motion. So this is your topic. You have to learn and practice this derivation. This is a small derivation and it gives you 4 marks. Therefore, you have to learn it. Okay, dear student, in next class we will study about the terminologies of wave and sound. Thank you.